Welcome to the deep dive. If you're anywhere near software development or QA, well, you've definitely heard the drumbeat about testing environments. We're talking about that really aggressive marketing you see from the big cloud testing platforms, services like BrowserStack. Their core message, and they push it hard, is that their pricey, real device cloud is basically the only professional, the only valid way to test your apps, especially across all the different OS versions and devices out there.
And that's exactly the narrative we need to scrutinize today. We're aiming to get past the hype. Our sources are actually suggesting this cloud model isn't quite the perfect solution it's made out to be. It has some pretty serious, sometimes hidden downsides, particularly for, individual developers or smaller teams, people who aren't giant corporations. So we're doing a critical look at those drawbacks, and we really need to reconsider the value of cheaper alternatives, things like visual simulators, maybe like iPadian, which the marketing tends to just brush aside.
Okay, let's jump right in then. If the big promise is all about efficiency and scale and testing everywhere, what's the main barrier, the one thing the shiny brochures don't really want to talk about?
Well, it really boils down to one thing: the cost. It's often prohibitively expensive, and that creates a pretty significant financial hurdle. Now, okay, to be fair, if you're a huge company like a Fortune 500, then yes, the cloud model can be a massive saving compared to building and running your own giant physical device lab with hundreds of phones and tablets.
But hang on, that comparison itself feels a bit loaded, doesn't it? It sets it up as cloud versus giant lab.
Exactly. It completely skips over most of the actual market.
Yeah, the vast majority.
It ignores the solo developer, the small startup team, maybe a student working on a project, or even open source contributors. For that huge group, buying into these expensive cloud plans just isn't realistic. Think about an Apple developer, right? They need to check how their app looks on different iPhones, different iPads, but they can't possibly buy every single device. So for them, using free tools like the built-in simulators or low-cost visual tools like iPadian perhaps, it's not just a nice-to-have, it's essential. It's what allows them to test at all.
And it's not just the upfront subscription cost, is it?
Yeah.
Our sources really dig into something they call the parallel testing task. That sounds not great.
Yeah, it's a bit sneaky. The pricing can look okay at first glance, maybe for a basic plan, but the costs shoot up really fast as soon as a team needs to scale their testing. This parallel testing tax kicks in when you need to run multiple automated tests at the same time parallel execution.
And just remind us, why is running tests simultaneously in parallel so important for modern teams?
Because that's how you get speed, right? That's fundamental to DevOps. If your whole test suite takes, say, 4 hours to run one test after another, you simply can't ship updates quickly. To do proper continuous integration, continuous delivery, you need to run potentially hundreds of tests in just a few minutes. So imagine you start with maybe 4 parallel test slots, but then your team grows or your app gets bigger, and suddenly you need 20 slots to keep up that release speed. The price jump to that next tier can be absolutely massive. It creates this huge financial choke point right when you actually need to scale up. You're basically paying a heavy tax just to maintain your speed.
So the company gets comfortable, maybe relies on the convenience for a bit,
Right.
and then bam, they hit this exponential cost increase when they need to go from, 2 parallel tests to 10 or 20.
Precisely. And then there's the way they structure the deals. These big platforms often push really hard for annual contracts, or maybe high-cost monthly plans with a big minimum commitment, so you're locked into paying a high fixed price even if you don't use all that capacity all the time. Maybe your testing needs dip in certain months, but you're still paying for the peak. It's not always like a true pay-as-you-go model that some smaller players might offer. It feels more about locking in revenue than offering real flexibility.
Okay, so the cost argument's pretty clear. It can be a real barrier, especially for smaller outfits. But let's say you are paying that premium price. You'd expect a top-notch, seamless technical experience, wouldn't you? And this is where our sources say things get really interesting. There seems to be a gap between the real device promise and the actual day-to-day user experience.
Oh, absolutely. The marketing talks all about the physical device, the real hardware, but they conveniently forget that you, the tester, you're not holding that device. You're interacting with it remotely, usually through a compressed video stream from a data center, potentially thousands of miles away. And that remote layer, it introduces some unavoidable and frankly often infuriating technical problems.
And the most obvious one would be lag, right?
Yeah.
Input latency.
Yeah, manual testing can become a real pain because of the lag. I mean, think about trying to play a fast-paced online game with terrible ping. Every action is delayed, your reactions feel sluggish. Now apply that to trying to test subtle UI details. Are the animations smooth? Is the haptic feedback on an iPhone feeling right? Are quick swipes responsive? You're trying to judge these things based on a video feed that's already slightly behind reality.
It must make testing things like uh, quick multi-touch gestures or maybe precise drag-and-drop interactions almost impossible to get right.
It does. That lag makes it incredibly difficult to truly validate those timing-sensitive, tactile experiences that really define a quality mobile app, especially in the Apple ecosystem where that polish is expected. So that remote visual-only interaction immediately limits how useful it is for anything needing that real-time physical feel.
But hold on, what about automated testing? Surely the automation scripts don't care about visual lag in the same way a human does.
That's a fair point, but automation runs into a different set of problems. It suffers from performance inaccuracy. We hear a lot about flakiness tests randomly failing, unexpected session timeouts, tests suddenly running incredibly slowly. And often these issues aren't caused by bugs in the app itself or even the test script. They're linked to the network connection between your test runner and the cloud device grid.
So the test works fine one minute, fails the next, and it's a nightmare to figure out why.
Exactly that. You end up with a lot of false negatives. The test report says failure, but the application code is actually okay, and the result is just wasted engineering time. Hours spent debugging flaky tests that failed because of some network hiccup in the cloud infrastructure, not a real bug. You end up paying all that money for parallel execution just to have tests fail randomly and maybe have to rerun them sequentially anyway, to be sure.
And we shouldn't forget the visual side either. If you've got designers needing absolutely pixel-perfect validation,
Right.
checking tiny color variations or slight misalignments, the fact that you're looking at a compressed video stream could actually hide those subtle visual bugs, couldn't it?
That's a fundamental limitation. The compression needed to stream the video can introduce slight distortions or color shifts. So if your job is to catch that one pixel off or that slightly wrong shade of blue, the video stream itself might actually prevent you from seeing it. It could easily let a visual defect slip through, only for a real user to spot it later on their actual device.
Okay, let's shift gears to the real nightmare scenario. A test fails. If just running tests remotely can be frustrating, trying to debug why something failed remotely sounds like it could be exponentially harder.
It really can be. Our sources call it guesswork and failure analysis because when a test fails in that remote cloud environment, you've introduced extra layers of complexity. You're often left trying to figure out which of several possible things went wrong.
Okay, walk us through those potential culprits. What could be causing the failure?
Right. So first, okay, it could genuinely be a bug in your application code. That's possibility number one. Second, it could be a mistake in your test automation script. Those are the two you'd expect in any testing setup. But with the remote cloud, you add number three, the network connection itself, specifically the local testing tunnel. That's the secure connection you need to let the remote device access your app running, say, on your internal development network. Setting that up and keeping it stable can be really tricky and notoriously flaky sometimes.
Okay, so app bug, script bug, or tunnel flakiness. What's the fourth possibility?
The fourth is the cloud provider's infrastructure itself. Maybe there was a momentary network blip within their data center, or the specific device assigned to your test became unstable for some reason, or maybe there was an issue with their grid management software. Trying to definitively figure out which of those four things caused the failure is way, way harder and more time-consuming than diagnosing a failure on your own local machine or even a local emulator where you have direct access.
And this complexity really highlights the issue of control, doesn't it? By moving to this kind of closed third-party ecosystem, what are dev and QA teams actually giving up?
They're fundamentally giving up direct, low-level control. Your team becomes totally reliant on the vendor's schedule and capabilities. Need a specific beta version of iOS or a particular security patch applied immediately. If the cloud provider doesn't offer it yet, you just have to wait. Need to do some really deep custom debugging, maybe manipulate things at the OS level that go beyond what their standard tools allow. You probably can't. A local setup gives you full access, like having the keys to the whole car. The cloud often gives you a limited dashboard interface.
But couldn't someone argue that's actually a benefit? You pay the vendor precisely so you don't have to worry about updating devices, managing cables, patching OSs.
And that's a valid point for large-scale maintenance, definitely. It is a convenience, but it's a trade-off. You trade that granular control and autonomy for convenience. And that trade-off also touches on security. We should probably talk about data security concerns here. These platforms are always quick to highlight their compliance certifications. Things like SOC2 compliance.
Right, SOC2. For listeners maybe not deep in the compliance world, what does SOC2 actually tell you when you're thinking about putting your company's sensitive code onto someone else's remote machine?
Okay, so SOC2 is basically an auditing standard. It reports on how a service provider manages customer data, looking at criteria like security, availability, processing integrity, confidentiality, and privacy. It's an assurance that they have certain processes and controls in place. However, and this is the key point for developers, despite those assurances, the very act of sending your proprietary, maybe pre-release application code, arguably your company's most valuable asset, onto a third-party cloud platform, inherently introduces more risk. And it adds more complexity to your security oversight compared to keeping everything contained within your own secure network. You're adding an external dependency, an external point of trust, or potential failure.
That makes sense. So compliance checks the procedures, but you're still handing over the keys, essentially.
Exactly. You're trusting their implementation of those procedures.
Okay, so we've done this pretty critical deep dive. We've looked at cost, performance, debugging, control, even security. Let's circle back to that initial marketing message. The cloud is the only way. What's the main takeaway we should leave people with?
I think the critical takeaway is this. We absolutely have to acknowledge the real value the cloud does offer. It's a seriously powerful tool for large organizations needing massive scale and device coverage. That's a genuine need, and the cloud solves it well. However, the constant message that cheaper options like local emulators or simulators such as iPadian are somehow unprofessional or unsuitable for any real testing, that feels like a calculated move. It seems driven by a desire to push everyone towards their expensive subscription models rather than acknowledging different tools fit different needs.
So they're basically trying to position anything less expensive as fundamentally flawed, just because it doesn't fit their business model.
Pretty much. Our sources really emphasize that a smart professional QA strategy shouldn't be about dogma. It should be about using the right tool for the right job at the right time. Yes, that might mean using an expensive real device cloud for crucial final regression testing across a huge matrix of devices. Absolutely. But it can, and probably should, also involve using a quick, cheap visual simulator like iPadian for early-stage layout checks across platforms, or a free local emulator for really deep debugging where you need total control. The cloud is a resource, a powerful one, but it's just one tool in the toolbox. It's not a mandatory doctrine you have to follow.
That's a great way to put it. So quick recap of the main drawbacks we discussed. The high cost, especially with that parallel testing tax, the performance hits from lag and network flakiness impacting both manual and automated tests, and the debugging headaches caused by that remote abstraction layer.
Exactly. And that brings us to maybe one final thought, something for you, our listener, to think about. If these high financial barriers really do make it harder for independent developers, for students, for small startups to access comprehensive testing environments, meaning maybe they test less or only test on the one or two devices they own, what's the bigger picture effect? What impact does that reduced access to thorough testing ultimately have on overall software quality across the board? And maybe even more importantly, what does it mean for innovation in the tech world if potentially great ideas can't get properly tested early on? Something to mull over.